Doesn't matter if you just started or you use JavaScript every day, there will always be things which might surprise you. So let's see some best practice and common mistakes to avoid being caught by surprise. Let's start from variable declaration. If you're using var, stop using it. Const and let are all you need, and they behave more like you expect, with a block scope visibility. Let means that the variable can be reassigned. Const means that the variable cannot be reassigned, so if you assign a number or a string, you cannot change it, since those are immutable. But if you assign an array, you can still push, remove, and edit values. Same thing with objects and fields. But you cannot reassign the variable. This because const means that the variable name cannot be reassigned, not that the content is immutable. The placement of variable declaration is often overlooked and can make code difficult to read. If you look at this code, A is declared and assigned in the beginning, but is not used until the last line. And the object allocated in the beginning is not even used, since the last line replaced it with a newly assigned one. So the first thing to keep in mind is to declare the variable near where it is used, and avoid allocating object if not necessary. This practice becomes even more important, especially if your function has early exit, like in the example. In this case, objects were allocated and not even used, which basically means that we wasted time and memory for nothing. So keeping variables near where they are used allows to save memory and time in case of early exit, and will make code more readable, since everything should be close to where it is used. Sometimes the syntax makes things look easy, and you forget what is going on under the hood. If your code looks like this, where you keep accessing the same inner object or you look up the same key from a map and so on, you're wasting a lot of time, and your code is slowed for no reason. You should not be afraid of using variable. If you look up something more than once, especially if you're in a for loop, use a variable to store the result of the lookup. The code will look much clearer, and it will be simpler to maintain and will run faster. Also, you should always assume that calling a function will result in a large amount of computation. Again, storing the result in a variable will improve your code. Choosing the best data structure for the job is always something to keep in mind. For example, sets are useful when you want to store unique values and you want to check if a value is in there. When you have a validation list and you want to check if an item is in there before doing something with it, or you want to iterate over something and you want to check if you already processed that item before executing the operation, a set instead of a list is a good candidate. Otherwise, you'll waste a lot of time scanning over and over the array. Includes, contains, index of, and similar function will check each item in the array to find if something is in there. They are not different from a for loop checking for the data. The problem with using linear search is that it may seem fast enough when you're testing it, but when you'll be in production with a lot of more data coming in, your code will be getting slower and slower. In this case, switching to a set is easy. The add method will take care of everything and the operation always takes constant time. You can replace your include, contains, index of with has, and you have a constant time operation instead of a linear time operation. For I, for of, for each are what you use to iterate over an array, but map does a different thing. I've seen a lot of code using map as a for each, and if you see someone doing that, you should stop them. Map should only be used to transform the input. It creates a new array with the result of calling the provided function on every element. Using map is the same as writing a for loop and pushing the result of a transformation into an array. So please stop everyone using map as a for each. If you use arrow function, watch out for curly braces. Without curly braces, the result of the computation is used as a return value. But if you use the curly braces, you must specify the return, otherwise you'll get undefined as the return value. Since we are on the topic of callbacks, can you guess the output of this code? Yeah, probably not what you expected. But in this case, it's not some weird JavaScript behavior. You may expect that passing the parseInt function reference is equivalent to using the arrow function with the value parameter, but it's not. Map and other commonly used functions like filter, group, every, find index, find last index expect a callback with 3 parameters: the value, the index, and the array. So what happens is that the 3 parameters are passed to the parseInt function, and the second callback parameters, the index, is used as the radix for the parseInt. So the output is that one. When you pass a function reference, watch out for the callback parameters. And if you have optional arguments or optionals may be added in the future, it's better to use an arrow function. Optional parameters are not the only thing to watch out when you work with callbacks. The code here seems okay, right? We pass the method bar of the object foo as the callback to the test function. But if we run it, well, we get undefined. If you like to pass around object methods as callback, you should watch out for problems around the this keyword. In JavaScript, the this value depends on how the method is called. In the example, the this that the bar method expects is not the foo object, but it is undefined. To fix the code, a solution is to use a wrapper function. In this way, we call foo_bar with the foo as its own dis. But let's try the same thing with something asynchronous, like setTimeout, setInterval, or a fetch. Instead of printing 1, we got 2. This is because the wrapper function is executed with the last assignment of foo. To solve this problem once and for all, we can use the bind method, which creates a new function that when called will use the provided value as this. Another common mistake I see is being misled by the sequential execution of the code. If you call a function and pass a callback, that callback may be executed sometime in the future. The common example are setTimeout or HTTP requests using fetch or similar. The code keeps going, so you can't expect that the result produced by the callback is already available in the next line. Instead, you should use the callback to react to the events that you'll receive. When you're computing or fetching multiple values to then iterate on them, the yield keyword may be a better alternative to collect the values in a list. Generator functions allows you to declare a function that behaves like an iterator. You can compute an item and return it to the caller as soon as they are ready, using the yield keyword. You can also have a synchronous generator and use them using the for_await. This allows to fetch or compute the items only if needed, and you avoid keeping in memory a lot of stuff that you may need only once during the iteration. When it comes to comparing things, JavaScript is a bit weird. As a general rule, it is better to use the strict equality operator instead of the loose equality operator, because it checks both value and type. This promotes type safety, prevents unexpected behavior, and produces predictable result. There are cases with null and undefined where you may want to use the loose equal operator, but in those cases, from a readability point of view, a simple not may be more clear. Sorting an array should be easy, right? There is a built-in sort method. But do you know what is the output of this code? Yeah, probably not what you expect, but hey, it's JavaScript. Elements are converted into strings and sorted lexicographically. If you want to sort numbers, you must provide your own comparator and return less than 0 if A is less than B, greater than 0 if A is greater than B, or 0 if A and B are equals. Aside from the language decision to convert everything into string, comparator functions are the things that you need if you want to sort an array based on more than one key. If you want to sort by surname name or by age surname name, you can compare one key at a time. If the result of the comparison is not 0, you stop right there. If the result is 0, you keep going. JSON stringify is one of those methods that you probably use without thinking too much about it. But if you're using map, sets, array buffer, or rather an endless object, you should be aware that they will not be serialized as you might expect. Fortunately, for all the objects not converted automatically, you can use a custom transformation method. This method, passed to stringify, will be called on each object, and it should return a simpler object that can be converted as JSON. MathRandom is something that I see used a lot to generate IDs. But please do not use MathRandom to generate UUIDs or any ID. Using a pseudo-random number generator to generate an ID is a bad idea, because they have limited period of randomness, which means that over time the same sequence of values will be generated, and you will end up with collision. The standard crypto API provides already a method to generate UUIDs and a method to generate cryptographically strong random values, so you should use those instead. The crypto module also provides APIs to generate a digest of the given data supporting the various sizes of SHA function. There are also methods to encrypt and decrypt data with both symmetric and asymmetric encryption algorithms supported. If you're interested in this topic and want to see code example, check out the specific video about encryption linked below. So to recap what we have said, do not use var, use let and const. Declare variables near where they are used to improve readability. Don't spend time for the same lookups, use variables, they are cheap. Choose the right data structure and learn about time complexity of the algorithm that you use to avoid surprises in production. Map is not a for each, use it properly. Be aware of callbacks and optional parameters to avoid getting weird results. Watch out when passing method as a callback, use bind or arrow functions. Be aware of asynchronous code. Even if the code is written sequentially, a callback may be called later. Be aware of comparison, use the triple equals as much as you can. Keep in mind that sort method converts element into strings, and you should provide your own comparator. JSON stringify may not work as expected on all the types, but you can provide a function to convert the unhandled objects. Avoid using MathRandom for IDs. Use the crypto module random values function if you need a secure random. And remember that there is a standard library for digest and encryption. If you have any question or want to know more, leave a comment below.